Alrighty, now we're starting free response question 3 of the AP Calculus exam from 2024. So what we want to do, first thing is we're going to do a sketch. And I always love these types of problems when we're doing differential equations. Part A wants us to sketch the slope field, and I promise you it was as easy as it may have seemed. We needed it to cross through this point here and go all the way through. All I like to do is when I'm doing these types to say, hey, follow the lines, literally follow the lines, and you would have gotten your point there for part A. Now, for part B, I wanted to jump in here because we're going to be talking about maxes and mins. And we must understand, one, how to find a critical point. A critical point is when f prime, or in this example, our dh, which was given here, dh over dt is equal to 0 or undefined. Now, don't forget about that undefined piece, but it's not important in this problem because there's no fractions, but that is what a critical point is out here. So if we want to find what the critical point is, well, let's jump right into it then. Step 1 would be to set this thing equal to 0. And when would this thing be equal to 0? When I say this thing, our function dh dt, it would be equal to 0 when cosine of t over 2 is equal to 0. All right, so if we do the math here, this is why trig and understanding our unit circle is so important. Cosine is equal to 0 in a couple places. Pi over 2 is 1, and 3 pi over 2 is another. And then when we multiply by 2 on both sides, we end up getting pi and 3 pi halves. And I ended up circling just pi because think about our domain. Our domain for this problem is going to be from 0 to 5, and 3 pi would be outside of our domain. So when we're trying to do a sign chart, I like my sign charts like this, and this right here will represent the derivative, dh dt. We're going to test some points. If we test a positive, or we test a number between 0 and pi, good number would be 1. When we plug 1 in, we end up getting, or it has to be a number bigger than 1, yep. So let's try 2. So when we try 2, we end up getting a positive number, and if we try a number bigger than 3.14, like 4, we get a negative number. And just because of that, that tells us that we have a max at our critical point, x equals pi. Now, for that justification, I always say we want to have a full sentence for our justification. Boom, there's a max at t equals pi because the derivative is positive on the interval from 0 to pi, and then the derivative is negative after on the interval from pi to 5. And that will be a complete answer to get you full credit. All right, see you in the next one.